is Anika, and I'm from the Discovery staff, and today we're going to do a question on high blood pressure and blocking. So a group of researchers wanted to know if a new pill used to treat high blood pressure worked on men on Medicare, right? A group of 500 men on Medicare participated in a study. Half the men were randomly assigned to take the new drug, and half were given a plain sugar pill, right? So neither the patients nor the doctors knew who evaluated them, and none of them knew who was in which group. Right? Both groups said they felt better, but there was no difference between the two groups in average blood pressure. So we can see here when trying to decide which type of study we're dealing with, right? First of all, we know that this is an experiment, right? An observational study. In an observational study, the researchers are just observing certain qualities of the subjects who are participating in the study, right? They don't get to decide which group subjects belong in because they can't control that. In an experiment, researchers have the power to decide which subjects, right, can belong in which group. They can sort of have a method for that, whether that be random assignment or something else, right? So we know right away that this is an experiment because we have these two, the control group as well as the experimental group, and that the fact that we have power to decide, which person belongs in which group. So we can also see here that these subjects were randomly assigned to either two groups, right? Which is one is the control group, which is the men who were given a plain sugar pill, and the other one is an experimental group. And the way we divided these was random assignment. So right away we know that this is some sort of randomized experiment, right? Since we're dealing with that random assignment. Now we know that there's a control group involved, right? There's a plain sugar pill that some of these subjects were given. So we know that this is also randomized controlled experiment. Right now, our last step is to decide, is this a double blind or, a single blind experiment, or is that even involved? Now here it says neither the patients nor the doctors who evaluated them knew who was in which group, right? When you have neither the doctors nor the patients knowing which subject belongs in which group, that is a double-blind experiment. When only the doctors know which subjects are in which group, but the subjects themselves don't know which group they belong in, that is a single-blind experiment. Here, this is a double-blind experiment. So our final study type, we can say that this this situation we have is an example of a randomized control double-blind experiment. Now, as for a conclusion, it says here both groups said they felt better, but there was no difference between the two groups in average blood pressure. So when we look at the actual, blood pressure between the two groups, since there was random assignment done, it means that there shouldn't be any other confounding variables that may affect our final result, right? That may have any effect of the treatment on the final conclusion. So here, since there was no evidence between these two groups and that random assignment was involved, we can safely say that both the sugar pill and the new drug, they kind of work the same, right? Since that blood pressure in the end, there was no significant difference. So we can say here that both the sugar pill and the new drug, right, work the same because that average blood pressure, right, there was no really statistically significant difference between these two groups, between that controlled group, which took that placebo, the experimental group, which took the actual treatment. So now we have another part of the problem, right? Suppose 50 of the men were very old, and the researchers want to make sure that these very old men are exactly evenly divided between the treatment and the control groups. And I know I've been saying experimental group, treatment and experimental group, they're the same thing, but they don't want to introduce bias, right? What should they do? So essentially, if we have our, entire pool of, it says here 500 men, right? So that's 500 men. The best experimental design you can kind of the most optimal design you can come up with to make sure that bias isn't introduced by a confounding variable such as age is to actually divide this, large sample of 500 men into our two groups first, right? So here we can have our first group, which is going to be the 50 men who were, very old. So we can say here, this is the 50 men who were very old. And then the second group would be basically the 450 men who are like not old. And this symbol, that's the not symbol. And now once we have divided that entire sample into these two groups, then we can perform that random assignment. So we can randomly assign half of these men to our control group, right? So half of these men, we can say that, for example, this is our control group, and then we have here, this is our experimental group. Half of these men can, who are very old, can be randomly assigned to the control group, and half can be randomly assigned to the experimental group, right? And then we randomly assign half of the men from the not old group into the control group, and the other half can be randomly assigned into the experimental group, right? So in that way, we have an even amount of very old and not old men in each of our control and experimental groups, right? It's the problem we want to avoid here is maybe the control group by chance. There's significantly many more older men in the control group as there are in the experimental group. Maybe there's 40 very old men in the control group, but we only have 10 in the experimental group, even though random assignment was involved. If by chance we have this scenario, then age would definitely be a confounding factor, right? Because these two groups are not very representative of that entire sample, which clearly included men of different ages, right? So in this way, when we have the optimal, like an even amount of very old and old men that is equally distributed between the control and experimental groups, we can avoid bias this way because the very old men and the old men are evenly distributed between each of these two groups. So hopefully this problem makes more sense. And if you have any questions, please let me know. And I hope you have a great day. Bye.